Let us look at how we would normally have or deal with null values in Java. We have a class here. The name of the class is person. We have a variable name and age, a simple constructor, and our toString method. Now, in this main class, we have our main method, but we also have a method called number. It accepts a position. Now, let us look at the code here. We have a person variable that is initialized with a null value. We then have a list of person objects. Now, we have an if statement. If the position given through the argument is within the range of this list, so from 0 to a position less than the size, which is normally the last element. In the case of this list, it should be from 0 to 2. So if the position is within that range, then get the person in that position and assign it to the person variable. After that, return the person variable. Now, if the position passed in wasn't within that range, that means the person passed or the person variable passed will still have that null value. Now, that could result in a null pointer exception. Let us look at what is going to happen. We create a variable and call the method number. Let us pass a random position, let's say position 0. When you look at the list, you can see the person in position 0 has a name, Daniel, and an age, 12. So let us say we want the name of the person passed. We should expect that what is printed out is Daniel, and that is what will be printed out when we run the program. Let us go ahead and run the program. We see Daniel. However, assuming we gave a position that was out of the range, the person variable wouldn't be given a person object and the value would still be null. Because of course the initial value is null. So that means it didn't change. If we try to access the name variable on a null person variable, we would get a null pointer exception. Let us run this and see our null pointer exception friend. Voila. We have null pointer exception. Now we can avoid these situations or help make it easy to handle using optionals. The main use case for optionals is in return types of methods. But to simplify this lesson, let us look at optionals individually. So I would comment out that method. Let us create an optional in this main method. It's a generic class, so you specify the type. I have created a variable, an optional of type integer, and have assigned it an empty value. Now, you need to think the way optionals think. An optional can either be empty or have a value present. So you have to understand this is how optionals operate. Either they are empty or have a value that is present. Empty or present. Just remember that. I would get into more details as the lessons move. Now, if you want to give an optional a value, you have to give it a value that is an optional type. I can't just assign this variable to a random integer value. I would have to use the optional.off. So this returns an optional of type integer and stores it in the variable called integer value. Now I can print out the variable. To get the value in an optional, I would call the get method. So what this does is it gets me the value that optional is holding. Because we called get, it printed out the value the optional is holding, which is 23. If I ran or printed out the variable without calling get, it would simply run the toString method found in the optional class. So that is converting the object to string, but not necessarily giving you the value. Because we're using modern Java, you can use var, but pay attention to some behaviors because optional is a generic class. If I create a variable and I say optional.empty, this optional is actually an optional of type object. That is why when I call get, you would see that the return type was object. I actually wanted integer. Now, the empty method is a generic method, so we can specify the type we want that method to work with. So I could say optional dot, then I specify integer empty. So now the next time I try getting or calling get, you would see that the return type is integer. You should have seen it from the highlight in IntelliJ. Now, this is a brief overview of optional empty and optional off. And we are just starting. We haven't started dancing yet. Let us begin to dance with the optional. You will dance optionally. Let us learn a little bit about the behaviors of empty and present. Firstly, the first maybe common mistake that might occur is trying to call get on an optional that is empty. Currently, this optional is empty, and I decided to call get in the printout statement. I would actually get an error. So before you call get, you have to make sure that the optional is not empty. Yeah, it might seem funny to you, but just wait. Let us go further. You will get a no such element exception if you call get on an empty optional. So how do you check if an optional has a value? There is a method called isPresent. So I can use it in an if statement. I would call the variable integer value dot isPresent. So if there is a value, I can now go ahead and call get. There is a method that makes this shorter, but for now, let us understand isPresent. We could even add an else statement. So if there is no value, I can print out no value. So when we run it, we should expect to see no value printed out. Yep. So that is how you check before you call the get. Remember, an optional can either have a value or be empty. Now, let's say that we give this optional variable a value. We will give it a value of 11. So optional of 11. By this, the optional is no more empty. So it has a value. So by the time we run the if statement, there is a value that is present. So it can go ahead and call get. Now, a very important tip. Do not pass in a null value or a variable with a null reference into the optional.off. If you do that, you would have an error, as you can see here. Now, if you think you're going to get a value that is going to be potentially null, there is a method called ofNullable. If not, anytime you're using optional.off, you should be sure that you're getting a value and not a null value. What this does is it has or allows you to actually pass in a null value. When you pass in a null value, it will still be empty. When we run the program, we still see no value printed out, because when you pass in null, it doesn't mean that there is a value present in the optional. It is still empty. So passing in null, the optional still remains empty. For example, if we call isEmpty after passing in null, we can see it printed out optional isEmpty. The method isEmpty returns true or false depending on if the optional has a value or not. So if it is not empty, it doesn't do anything according to the code we just wrote. So you have length of isPresent and isEmpty. Generally, when you want to use optional.off is when you have a value and it is not null. But if you potentially have a reference variable or a value that could be null, when you're creating a new value with that value, you can use optional.ofNullable. So generally, in a normal setting, if you call get on an optional that has a value, everything should run smoothly. But just like in real life, in some scenarios, that optional might not have a value. If you go ahead and call get, you might end up and will likely end up with the no such element exception. Now, there is a method called orElse. So what that does is, if an optional is empty, you can supply it with a value that should be used if that optional is empty. Now, orElse calls get automatically. So you don't need to say integer.value.get.orElse. Simply by calling orElse, you're trying to tell the optional, get me the value. Now, if that value doesn't exist or this optional is empty, use this value instead. Now, since this optional is empty, as we can see, it would return 100 because that is the value I provided in case this optional is empty. So we can run it and we can see 100 was printed out because the optional was empty. Now, if this optional had a value, for example, let us give it a value. It wouldn't need to run the orElse. It will simply print out 3 because orElse runs if the optional is empty. Remember, an optional can either have a value or is empty. Also, you should have noticed there is no public constructor of the optional class. There is orElse get. It is similar to orElse. The difference is it accepts a supplier. So we can implement it with a lambda expression and we will simply return 100 here. Because it's a supplier, we can do more powerful operations with it. But for now, let us just, return 100. if you're returning a simple value, you could as well use orElse instead of using orElse get. If the optional is empty, of course, it will print out 100. We have another method called orElse throw. Now, what this tries to do, it also accepts a supplier, but it tries to allow you decide the exception that should be thrown when this optional is empty. In this situation, I told it to throw new illegal state exception. You might not want the default exception being thrown when the optional is empty. You might have your own custom exception instead. You could use orElse throw to specify the exception that should be thrown when it is empty. I would prefer to use the method reference here, so I would use the method reference instead of the lambda expression. We have orElse, orElse get, orElse throw. There are some other similar methods here and there, but these are I think the main three which you should be using and would cover most of the use cases that you might come across. I hope you're enjoying optional so far. We still have some more interesting methods to go through. We have a method called map. Now, we can use this method to transform the result or the value in the optional before getting it. So this map accepts a function and we can implement it using a lambda expression. Whatever is returned is going to be what is going to be received when we call the get method. Now I have said multiply I. I is representing the value in the optional. Multiply it times 10. Then after that, call get. What this will do is to get 45, multiply times 10, and by the time I call get, the value would be 450. As simple as that. Now you can transform a value from integer to integer, integer to even string. For example, I could say I plus lines. You know, when you have an integer and you concatenate it with a string, the result is a string. So when we call get, what is going to be printed out is 45 lines. So it printed out a string where it said 45 lines because we said I concatenate it with a string, so 45 and lines into one string. Now, we could also have orElse. So instead of calling get, we call orElse. Remember that orElse also calls get. And then if the optional is empty, it runs what is inside the orElse, or it supplies the value you give to orElse. The type of value supplied by orElse is determined by the value returned from the map. If you notice, the orElse is returning or is supplying a string because the map transforms the integer to a string. The optional is not empty at the moment, so it still returns 45. Once it is empty and we run the program, you can see that it printed out no line. If we change the map result to an integer, let us make it an arithmetic operation. When we call orElse, orElse will have to supply an integer. So it can no longer supply a string. The type of value by orElse is determined by the type of value eventually supplied by the map operation. We have a method called filter. Just like the name suggests, we use it to filter values. So we can have an optional that isn't empty, but at the same time, we want to filter the value and check if it is the value we actually want. Now, the filter method accepts a predicate. We can implement that with a lambda expression. What am I going to do? I would say if I is 2, then get it. So only if the integer value stored in here is an integer of value 2 before it will pass through this filter. If the value stored here, and of course we can see that the value stored is 45. If the value stored is 45, and of course it is not 2, this filter method will return an empty optional. And if we call get on an empty optional, remember what happens? It will give us an exception. Now imagine if we actually said if I was 45. I is actually 45. So when we run it, it will pass through this filter. And when we call get, we can see the value. So a filter is like saying, hey, if this value, even if it's present, if it is not what I want, is as good as being absent. So give me an empty optional. We can chain an orElse to this call. So if I is 10, then let it pass. If not, instead of crashing, return or give it a value of 100. So because the optional value now is 45, it wouldn't pass through the filter. So an empty optional is going to be returned. Because the optional returned is empty, the orElse method would run and supply 100. By the time we run it, 100 is what should be printed out. Let us go ahead and run it. Voila! We see 100. So this is how to use filter, because you might have an optional that actually isn't empty. The only issue could be the value stored in the optional might not be what you want. So you can filter it and use orElse. Of course, we know that before we call get, we should make sure that the optional has a value. If there is no value, the code shouldn't run. And as we can see, nothing was run because the optional was empty. And when it checked if there's a value present, there wasn't any value. So the program finished without printing anything. We have a method called ifPresent. The name is similar and close to isPresent, so I don't know if that might be confusing. But this is how ifPresent works. If a value is present, do this. It accepts a consumer. So the value of the optional is passed in, and you can do what you want to do with that value. So this is like the short form of calling if a value is present and then doing a particular operation. You can just do it straight away. If a value is present, print it out. And you might ask, what if the value isn't present? Will it throw an exception? No, it wouldn't. It will simply not run. just like how the case of isPresent would not run if the optional is empty. So it is a conditional statement. If there is a present value, execute or run this code. There is another method called ifPresent or else. Now it accepts two parameters. The second parameter is an empty action that runs if the value isn't present. So let's say the value isn't present and you want something to run. For example, print out value 7. You can use ifPresent or else. Let us go ahead and make our number method to be using optional. Currently, it returns a type person. So the first thing we need to do is to change the return type to optional of type person. Now, the person variable in this method is of type person, so we want to change that as well to be optional of type person. Now that we are making this person variable optional, do not assign a variable that is an optional a null value. Do not do this. If you want the variable to be empty, we can use the optional.empty. But you are not advised to do this, to assign null to a variable that is optional. I would simply say optional.empty because an optional should either be empty or have a present value. Now, in the if statement, I am trying to assign a person to an optional of type person. So what I should do is, instead of doing it directly, I should call this personList.get and pass the value inside an optional.off. So I would call optional.off, and inside there, I will call the person list and get the person in the particular position. So I am returning an optional of person. Now, at the end of the method, by the time we return a person, it is either that person variable is an empty optional or an optional with a present value. As simple as that. So we have changed this method from returning null to returning a present value in an optional or an empty optional. Let us call this method in the main method. And we call position 1. If you look at the list, you can see position 1 is the person with the name David. If I call person.get and I run it, it should print out David and the age of that person. And this is simply using optionals, but let us play around and see the different behaviors. Assuming I call position 11, this list has only 3 elements, so there is no element in this list with index 11. If I call index 11 and I call get, on an empty optional, I will have a no such element exception. Remember, to avoid this, we can use orElse. Now, orElse should supply a person object. What this would do is, by the time we get the person optional variable, when we call orElse, it will try to get and check if it has a value. If it is empty, we are simply going to use the value provided by orElse. So when we run it, we can see it printed out James and age 90. because there is no element with position 11. So it returned an empty optional. We can also use filter. Now, this particular code is saying, I only want people with age greater than 20. Or else, give me a person with a name Sonia and age 29. Currently, I am asking for position 11, so there is even nobody with that position. So it quickly goes to orElse and provides Sonia. Position 0 is Daniel with age 12. The optional returned actually has a value. But when it comes to the filter wants someone with an age greater than 20. Since it didn't pass the criteria, it will return Sonia with age 29. However, if I call position 2, which is Jack, and he is age 30, when it comes to the filter, it passes the criteria. So it will be printed out. And when we run the program, we see Jack, age 30. And from there, you can see the power and beauty of using optionals. Sometimes you might not have the luxury of editing the code in a method. The former version of this method was simple. It returned a type person. It had a variable of type person that was initialized to null. So that means when it returned person, there was a possibility that the person could have been a null reference. This is a simple way of using optional. We can simply change the return type to be optional, and we only use optional in the code at the point of returning the value. So I haven't touched any major code in this method. Remember, in the former lesson, we actually changed the type of the person variable. Here, the person variable can still be null. So nothing really changed. I simply changed the return type and the way the value is being returned. Also note that I am using ofNullable. I am using ofNullable because the person variable can actually be null. So because it can be null, I would avoid using off. When you use ofNullable, anytime the person variable is null, that optional will be empty. So you can't have an optional that has a value that is present and that value is null. So it doesn't work like that. Once the optional is given a null value, it sees that as empty. So if I call position 9, there isn't any value with index 9. If I call person.isEmpty, it returns true. So even though I returned optional.ofNullable person, which is assigned a null value, the optional sees it as nothing. So it is empty. That is how you can use optional in already existing code. We can call the ifPresent method. Remember that this executes if the optional has a value. If it doesn't have a value, it simply ignores this call and nothing is run. We call position 1 and we can see that the person in position 1 has a name David and age 11. In the ifPresent method, I said print out the person's name. That is why you see p.name. Now, this is how optional behaves. It's a nice tool in Java, and you can use it to help you avoid null pointer exceptions and, avoid errors. Understanding optional will also help you in understanding some return types. from the JavaStream API.